Hi students, let's see a topic in magnetism. The force on the current carrying conductor placed in a magnetic field, or the magnetic force on the current carrying conductor. Magnetic force on the current carrying conductor. Here we are taking a conductor which is having a cross sectional area A and the length L, and the electron is traveling with the velocity Vd, and the force experienced will be perpendicular to the both velocity of the electron as well as the magnetic field which is applied. Magnetic field is applied perpendicular to the movement of the electrons. So the cross line indicates here the direction of the magnetic field, that is into the paper. The density of the mobile charge carrier is taken as a small n, the drift velocity Vd, and the current I. From the electrons flow, mobility of the charge carriers, we know I is equivalent to N into E into A into Vd, where A is the area of the conductor and Vd is the drift velocity of the electron. Again, the density N can be given as total number of the electrons divided by the volume, that is capital N divided by V. V value is area into the length of the conductor, A into dl. So the capital N can be given as A into dl into N, that is Na dl. The force of the carrier can be given in terms of, from the Lorentz force we know, whenever the charge particle is moving, it experiences a force called the Lorentz force, that is F equivalent to Q into V cross B. And for n number of the charge carriers, F is equivalent to N into Q into Vd cross B. Then N can be replaced as N into small n into A into dl into Q into V cross B. Rearrange the equation to get the value and substitute the value of the I, which is N into E into A into Vd. You will get F is equivalent to IL vector cross B vector. In magnitude, we can write F is equivalent to BIL sin theta, where theta is the angle between the moment of the charge carrier, that is where velocity is acting, V cross B, where we keep the conductor in the same direction, in which direction the current flows. We need to take the theta between them. If we compare the length of the conductor and the magnetic field acting at this point, it is 90 degree. So theta is equivalent to 90 degree, F equivalent to BIL.